the part B. So this part is a bit challenging. So we are going to do OP in terms of lambda I and j. So let's go to the diagram OP. So just now if you read the question, this is 1. This part is 1, the ratio. And then this is, we focus on lambda. This is lambda. So AC, we have the vector already, right? AC is 12 and negative 8 just now. We got ready. Now we are asking to find the OP. OP is here. Let me show you. This is the OP. Now let's say OP is here. We are going to find the OP in terms of lambda. So actually we can use a ratio theorem that you learn in coordinate geometry. So this point was given, right? This is negative for negative 1 and 3, right? Alright, then this one is the point C was given 11 and negative 5. Now let's use a ratio theorem that you learn in coordinate geometry. So it's the same like what you learn in a straight line. Here P is xy, right? P is xy. Let's see, we are not sure what is OP. Okay, so we have the ratio here 1, we have lambda here. P divide the line internally. This is negative 1, 3. This is 11, negative 5. Now let's use a ratio theorem to solve this. Then we convert vector. This one will times with the 11. Lambda will times with this negative 3 over the total ratio 1 plus lambda, right? So we can say that for the x is equal to 1 times 11 plus with the lambda times with negative 1 over total ratio 1 plus lambda for the x. For the y, let's simplify, is 11 minus lambda over 1 plus lambda. So for the y, we can do the same. Is still 1, but we will times the number beside 11 for the y coordinate. We will write like this first, 1 plus lambda. Alright, so I'm going to teach you the way. So we will use 1 times with a negative 5. Just now was 11. Here negative 5, lambda, and then 3 beside negative 1, right? So we have the answer, which is looks negative 5 plus 3 lambda over 1 plus lambda. So we have found the point P in this way. Point P, which is 11 minus lambda, 1 plus lambda, and negative 5 plus 3 lambda over 1 plus lambda. So if the question asking for vector OP, so we will write as 11 minus lambda over 1 plus lambda I, right? Plus, make sure you put bracket here, plus negative 5 plus 3 lambda over 1 plus lambda j, right? That is how we write the unit vector when we have the vector in terms of the vector column, or you can say the coordinates. These are the point for the x and y for the point P. We'll do the same for the OP in terms of the mu. So if I'm going to solve the OP in terms of mu, so let's see. I'm going to focus to the mu. Here is 1, here is mu, right? So now we're having a line like this. This is P, right? Let's say this P, x, y. And then the point B was given 0, negative 1. And then point D is 3, 2, right? point D here is 3, 2. So we will use a ratio theorem first before we apply to vector. This is 1. Let's label this is 1 ratio. This is mu. So we will take 1 times the 3 and then mu times with the 0. For the x is 1 times the 3 plus mu times the 0 over 1 plus mu. So for x we can simplify to just 3 over 1 plus mu. For y we will do the same. Y is 1 times mu times over 1 plus mu. So beside the 3 is 2. Right, beside the 3 is 2. So this is 2. And beside the 0 is negative 1. Ready. So the y is 2 minus mu over 1 plus mu. So we have the coordinates for the OP in terms of mu, right? So we write in terms of vector. So it's 3 over 1 plus, oh, this is mu. This is mu. 3 over 1 plus mu. So that means our OP is 3, 1 plus mu, I plus 2 minus mu over 1 plus mu j, right? So we actually convert the coordinates into vector. This is our y. This is our x for the point P. So if we write in terms of I and j, this is the answer for OP in terms of the mu. Remember to put bracket, right? For part C, let's see. Hence, find the values of lambda and mu. Okay, how to find the values is we are having two vectors which are exactly the same OP, right? So we are going to solve it like this, you know. So we will say this component equal to this, right? And then this one will equal to this one. Wow, it looks very complicated. Now let's solve it. In terms of how many I, how many j, you have two OP equal vector. So you can write two equations by comparing their scalar component.